Let's factor a difference of cubes. So for difference of cubes, we actually have a formula that we should follow. So difference of cubes simply means one cube minus another cube. So a cubed minus b cubed. And then that factors like this, a minus b. So this sign we copy it here, and then a squared plus ab plus b squared. So if it's a difference of cubes, then we will have a minus here and then plus everywhere else. If it's a sum of cubes, then this would be plus, but this would change to minus. We'll talk about that some other time, perhaps. So let's factor this binomial here. It is a binomial because it has two terms and meets the rest of the requirements for being a polynomial. So as always, when we factor, we first need to try and find, do those terms have something in common? We need to find a greatest common factor. And then, since there is no x in the second term, they don't have x in common. But we could analyze 16 and 54. Both of them are even numbers, so we know for sure that they have 2 in common, so we can take 2 out. If we take 2 out, if we factor it out, then this becomes 8, and we still have x cubed. And then this becomes, the 54 becomes 27. Okay. Now 8 and 27, they don't have anything to factor out, so we can't keep factoring anything else, which means that we found the greatest common factor, right? After we did that, we always need to check what's inside the parentheses. Can it factor some more? And we already have something cubed here, x cubed. If we look closer here, well, 8 is a perfect cube, and 27 is also a perfect cube. And we have a minus here. So this looks like a difference of cubes, like this one right here. We just need to kind of match it. So it looks kind of similar to this enough so we can use the formula. So 2, we always keep copying the 2 that's there. And then 8 is actually 2 cubed. So this is actually 2x and then cubed together. And then 27 is actually 3 cubed. So now this resembles this formula right here quite a bit. We have something cubed minus something else cubed. That's exactly what we have here. Something cubed minus something else cubed. Now in our case, what's under the first cube is 2x, and so that's our a. What's under the second cube is 3, so that is our b. So all we need to do is now follow this formula. So if we do, then we would have 2 again, this one that we copied down. And then it says here in the formula, first minus second, a minus b. Well, in our case, first is 2x. And then let's fix this x. 2x, and then second is 3, so it's just 2x minus 3. Now the second part of the formula, second set of parentheses here, says first squared, so 2x squared. So 2x, and then squared. And then the formula says plus, so let's put the plus there. And it says first and second multiplied together, so it's 2x times 3. 2x times 3. And then it says here second squared. So In our case, that would be 3 squared. So plus 3 squared, close parentheses. Now all we need to do is simplify what we can simplify. So nothing changes here. 2 and times 2x minus 3, that stays. But here we could kind of simplify it a little bit. So 2 squared is actually 4. So that's actually 4, and then x squared is just x squared. So this is 2x squared, 4x squared. And then here 2x times 3 is actually 6x. And then 3 squared is actually 9. And that will be it. We actually factored this binomial right here, which turned out to be difference of squares. And this is our answer right there. If you like the video, please click like, click subscribe, and as always, don't forget to smile.